Puppy support is a quadrotor that follows and protects your AR tag-equipped puppy. First, puppy support takes off and increases its altitude in search of the AR tag.
Once the tag is found, the quadrotor tracks the tag to the best of its ability. The quadrotor's adjustments are proportional to how far away it is from the tag.
Originally, we wanted the AR tag to be mounted on top of a turtlebot, but the quadrotor is equipped with a sonar-based collision avoidance feature that we were unable to override. This meant that we had to drag the tag on the ground. If no AR tag is found at the maximum altitude, it begins a search sequence. This sequence consists of a spiral that increases in diameter until the tag is found.
Maybe it'll still find it.
We see it.
The firmware on the AR drone pre-processes the video data. We configured it to detect oriented roundels, which look like the black and white tag seen in the video. The data returned directly from the AR drone gives us the X and Y coordinates of the position of the tag on a scale from 0 to 1000. We used that data to determine where the tag was detected in relation to the center of the camera, which allowed us to direct how the robot should move.
We're using the Node AR drone library, which is programmed in JavaScript. This provides high-level functions such as left, right, forward, and backwards. It also allows us to read the sensor data from the robot.
On the AR drone, there was no localization, and as a result, there was no way to command it to move one step forward or move at a given speed. It would also continue moving in a direction until it was told to stop. The solution in our spiral scanning function was to tell it to go in a direction for a predetermined amount of time, which we figured out through testing.
An issue that we had was that certain directions seemed more powerful than others after the quadrotor was recalibrated. This led us to introduce compensation variables to normalize the power applied to each direction. For example, we had to bump up power on the left motor and reduce power on the right motor during our scanning function to get a more consistent spiral.
Pretty good spiral, actually.
Yeah.
Is it gonna find it?
Yep, found it. We also had compensation applied to our altitude raising function. These variables were usually a combination of front, left, and up, or back, right, and up to get the quadrotor to rise relatively straight. Without our compensation, the quadrotor would veer off in a random direction when it was supposed to be going only vertical.
The Node Drone Stream library runs a server on our local machine, which is accessible to any other computer connected to the AR drone network. In order to serve the video to a web page on the internet, we would need to have a secondary network interface connected to the internet. The video actually streams pretty smoothly, but the recording and streaming video at the same time makes it look choppy.
Due to the low altitude testing environment, the camera viewing cone is small enough that minor turbulences in the quadrotor cause the tag to exit the frame. As a result, we added a last known course correcting position algorithm, or LKCCP for short. This allows us to find the tag if it's gone out of the frame.
The asynchronous nature of JavaScript meant that we had many callbacks, which made synchronizing the nav data and direction commands difficult. To solve this, we use throttled functions, which limit the number of times they're fired in a given interval.
We also had some problems with the durability of these robots.
Oh, what? Shit.
It didn't.
Oh! Ooh.
Why do you always go here?
Oh.
Go that way.
Are you gonna kill it? Hold on, I'm gonna like. Okay, I don't know.
What? Get the Don't go this way. Don't go this way. So what was the problem? Whoa.
Right. Front.
Why?
Our apologies. How many minutes?
Too far. Going up. Why?
I think the calibrations are wrong.
Uh-oh.
It's too high.
We see it right now. Now we're still seeing it. Oh god. Oh god. Forward.
Oh.
Up forever.
Where it goes up to the ceiling is not our fault. Nice catch. I think we're having issues that we're over top of that. Did I kill it?
Yes. Back. Too far back.
Right. Whoa, that was not our code.